First of all, there is some knowledges we need to know. 1. If the LED is connected directly, it may draw too much current from the Arduino's 5V output and burn out. 2. Arduino's digital output pins can provide a maximum of 40 milliamperes, but the safe level is around 20 milliamperes. Here we gave the resistor's value 220 ohm. Why do we use 220 ohm resistor? And the answer is the 220 ohm resistor is used to prevent the LED from getting damaged excessive current. How do we calculate the resistor's value? Well, we use Ohm's law to calculate the required resistance. Here V is voltage difference, 5 volt minus lead voltage drop. I is desired current, usually between 10 20 milliampere, also equal to 0.01, 0.02 ampere. R is resistance, and for a stand at red lead, also we use it in our circuit. Lead forward voltage is about 2 volt. So let's find the resistor's value. Resistance is equal to 5 volt minus 2 volt divide 0.02. 3 volt divide 0.02. And the answer is 150 ohm. But we use higher than that, 220 ohm, to guarantee ourselves. Here you guys can check what happens if we use different resistor values. You should be asked such a question here. Why do we use voltage difference when calculating resistance? Because we want to determine the actual voltage that drops across the resistor. The resistor's purpose is to regulate the current flowing trough the lead and protect it from excessive current. However, the lead itself also has a voltage drop. This should interest you. I hope you noticed because you will understand the connection between the topics here. It looks like a closed line? Now remember the Kirchhoff's voltage law. It says the sum of all voltage drops across a closed circuit will be 0. That is, in a circuit, the supply voltage source and the sum of the voltage drops across the components must be equal. Supply equals resistance minus lead. This is based on the principle of conservation of energy. In an electrical circuit, the energy that enters the circuit, supply voltage, must be spent by all components. In this situation, Arduino 5 volt, lead equals 2 volt. What is the resistance voltage drop? According to Kirchhoff's law, we will find 3 volt. Let's set up our circuit. Let's explain the manual triggering with jumper cable, temporary solution, method in detail. With this method, we will give a low 0 signal to the digital input pins on the Arduino without a button and make it act as if the button was pressed. In here, we connect the long leg of the lead in series with the resistor. We connect the other end of the resistor to pin 9 of the Arduino. We connect the ground part of the Arduino to the breadboard with a jumper wire. We connect the free short leg of the lead to ground. We connect a jumper wire to ground, so we will manually adjust the brightness of the LED. We also connect a jumper wire to the second and third pins of the Arduino for the same purpose. And all we do is touch the wires together like this. Here it shows how it works, but it is not visible in the camera's image frame. Don't worry, it will appear in the coming minutes. Electric plug connections. LED connection. LED's anode, long leg, connected to resistor. LED's cathode, short leg, connected to ground. Jumper cable connection. Connect one end to ground, and connect the other two is one for pin 2 and the other for pin 3. Imitate the function of the button by touching the other end to the second or third pin with your hand. Let's take a look at the code we uploaded to the Arduino. First, we define the variables. The const statement makes the variable we define a constant variable. That is, we cannot change its value later. We define that the LED is connected to pin 9, and we define the brightness increase as pin 2.brightness equals 128. The initial brightness of the LED is at a medium level between 0 and 255. That's mean. 0 LED is completely off 0% brightness. 255 LED is completely on 100% brightness. 128 LED is in medium brightness, 50% brightness. The reason we use the range 0 to 255 is because Arduino's PWM outputs are 8-bit. 8-bit means we can use 2 to the power of 8 equals 256 different values. Starting from 0, going up to 255, there are 256 values in total, since 0 is included. Step size equals 25 with each touch. The brightness of the LED will increase or decrease by 25 units. Pin mode, LED pin, output. LED is set as output. Pin mode, button up, input underscore pull up. And pin mode, button down, input underscore pull up. These codes mean that button up, pin 2, and button down, pin 3, will be used as inputs and the internal pull-up resistors will be activated. In Arduino, there is an internal pull-up resistor of 20-50 k ohms in each digital input pin. We activate this resistor using the input underscore pull-up command. We activate the internal pull-up resistor using input underscore pull-up, and there is no need to connect an extra resistor. When the cable is not touched to the pin becomes high. When pressed, it becomes low. Inverse logic. Analog right, LED pin brightness. Initially, the brightness of the LED is set to 128. Digital read, button up, equals low. If the jumper wire is touched to pin 2, if it is low, the LED brightness is increased. We use min function to prevent the brightness from being larger than 255. If the newly calculated brightness is larger than 255, the min function will return 255. If the new value is smaller than 255, the min function returns the smaller number. We use max function to prevent the brightness from falling below 0. For max function, if the brightness falls below 0, we choose 0. If the new value is larger than 0, the max function returns this value. Digital read, button up, equals low. If the jumper wire is touched to the second pin, if it is low, the LED brightness is increased. Brightness equals. The brightness of the LED cannot be greater than 255, so we limit it with the min function. Analog right, LED pin, brightness. The new brightness value is applied to the LED. Delay, 200. A 200 milliseconds delay is added to prevent button bounces. If the jumper wire is touched to pin 3, if it is low, the LED brightness is reduced. Max function is used to prevent brightness from falling below 0. Analog right, LED pin, brightness. The new brightness is applied to the LED. Delay, 200. Again, a 200 milliseconds delay is added to prevent button bouncing. What does the code do in summary? When the jumper wire touches the second pin, the brightness of the LED increases, maximum 255. When the jumper wire touches the third pin, the brightness of the LED decreases, minimum 0. Thanks to the internal pull-up resistors, we can use a jumper wire directly instead of a button. The brightness changes by 25 units with each operation. Step size equals 25. Thanks to delay, 200. Button debounce is prevented.